The strategy design pattern uses composition instead of inheritance to give different objects similar functionality. It creates a has-a relationship instead of an is-a relationship for your objects. What does that mean for you? It allows for more changes to the runtime behavior of your program, easier maintenance, and it avoids bugs where an object inherits a behavior that it shouldn't have. Let's begin with an easy-to-understand scenario. Consider we're building a role-playing game. In the game, there are mobs such as orcs and dragons, as well as playable characters, or clients. All of the characters in the game share similar features, such as the ability to attack other mobs, hit points, and a name. The client inherits from the base mob class, but has additional code such as networking tasks that it needs to perform. Now consider that there are many different weapon types in the game, such as spears, maces, and swords. Of course, orcs and players should be able to use these types of weapons, but dragons don't have posable thumbs. Their attack is breathing fire. If we just use simple inheritance to try this, we would end up with a different class for every mob and weapon type that just overrides the attack method. This is a terrible design nightmare, and we would end up with thousands of classes. So let's use the strategy pattern to come up with something better. Here is an implementation of the mob class. As you can see, it has a constructor with the name and the hit points of the mob we wish to create. Then there is the attack method with the mob that we wish to attack. There's various getters and setters that set the name and the hit points, but they're not important at this point. Below it we have the client class, which inherits from the mob class. It has a similar constructor and the networking code that we talked about. We won't be doing much with the client class in this example. It's just there to show how composition and inheritance work together. In our main function, we create two mobs, an orc and a dragon, with 20 hit points and 2,000 hit points. We then create a player with 450 hit points. The two mobs attack the player, and then the player attacks the dragon. At this point, our attack method is very simple, and there are no special attacks. Every mob just hits every other mob. We use a standard cout to implement this. And at this point, it appears that our program is running correctly. In order to implement the strategy design pattern to have interchangeable weapon attacks, we will create a new interface called attack behavior. We will then add this to the mob class as well as a setter that can change the attack behavior. Then we can inherit from this interface and have any kind of attack that we wish, such as mace attacks, sword attacks, spears attacks, and fire attacks. So we'll start off by declaring the interface and then implementing it. So we named it attack behavior. It has a public virtual void perform attack method with who we want to attack, who we want to attack, and who is the victim. Now here I'm going to have to include the mob class because we're using it, and since it's a circular problem, we're going to have to do a forward declaration. What that means is because iAttackBehavior uses mob and mob uses iAttackBehavior, the compiler will have issues if we don't forward declare it. So now we can make a mace attack implementation off of our base interface here. And we will just implement this method. We'll do that for swords and fire. So we'll start with the mace attack. Perform attack. We'll just use the same type of deal as before, just standard cout, but this time we'll have a special attack that crushes since we're using a mace. We'll do that for the sword and fire. with slash and scorch. Now that we have our implementation of our attack behavior interface, we can add it to the mob class using composition or the strategy pattern. So we'll add a pointer to a behavior within the class, and we'll include the interface and implementations, and we have to forward declare it again because it's circular logic, because they're both using each other. And then we'll do the set attack behavior method. And we'll set behavior to 0. So it's null when we start. So we need to implement the setter, which will be very simple. Let's do this behavior equals the behavior that we want to pass. Now when we attack, we'll call this behavior, and we'll perform attack by sending it this and who we want to attack. Now that all of that is done, but we might want to check and make sure that there is a behavior. And if there isn't a behavior, we could always do some type of secondary attack or something that all people get. Now we'll do a mace for the orc. Give it the pointer. We'll do the fire attack for the dragon. And the sword attack for our player. Now when we run the program, they each perform their special attack on each other. This was just a simple demonstration of how the strategy pattern works, but hopefully it shows some of the advantages of composition. For instance, you can easily change the runtime behavior of your program now. If a player wants to swap out their sword for a mace, you can do it just by again calling the set attack behavior method. It is also easier to maintain the weapon behavior implementations than it is to have 1,000 child classes of mob that just re-implement the attack method. You don't have to worry about your dragons using swords because they inherited that behavior somewhere along the line. Think of how easy it would be to extend the concept further and create a well-designed combat system for the game. That concludes the tutorial. Be sure to check out stdlib.info for the source of this example and for more tutorials and resources.